Hello, dear students. You are welcome to session 8 of Core Mathematics for SHS. So, for today, we are going to study on inequalities. Alright, so without much ado, shall we set the ball rolling? Okay, so before we commence, let's look at the session outline. So, basically, in this session we'll be looking at the various types of inequalities, and then we are also going to study how to solve linear inequalities in one variable, and then we also study on how to illustrate inequalities on the number line. Alright, so without wasting much time, let's begin. Okay, so what is an inequality? So an inequality, as the word suggests, means that the two expressions are not of the same quantity. Right? Unlike equations, with equations we say that whenever you have an equation, it tells you that the expression on the left hand side is the same as the expression on the right hand side. Right? But then with an inequality, it tells you that the expression on the left side is not the same as that on the right side. Right? It is either greater than or less than, or greater than or equal to, or less than or equal to. Right? And that gives us the four main types of inequalities. Right? So if it is not equal to, then it is either less than, right? So this is a symbol for less than, or greater than, or less than or equal to, or greater than or equal to. Right. Now, the positioning of the symbols with respect to their meaning, you have to take critical notice of it. Right. So you see the way the symbols have been positioned. Now we are assuming that the variable is in front. Right, so if the variable is in front of the symbols this way, then these meanings will apply. Right, so like this example, x is less than 4. So you see the pointed end is facing the variable x. Right, so then when the pointed end is facing the variable, then it becomes less than. Here it is greater than. So when the open end is facing the variable, then it becomes greater than. Now, when you have the pointed end facing the variable with a line beneath it, it is less than or equal to. And when you have the open end facing the variable with a line beneath it, it is greater than or equal to. Right? So these are the four main types of inequalities. Right? So like I said, mind the position of the variable in respect of the symbols. Right, so with less than, the pointed end must face what? The variable, just as you are seeing here. With greater than, the open end must what? Face the variable. Okay, so let's proceed. Alright, let's look at the number line. So the number line is simply sort of a calibration of numbers from the least to the greatest, or let me say that the numbers are arranged in an ascending order. Right, so let's look at this example here. So like you are seeing, we have -3, -2, -1, 0, 1, 2 and 3. Now clearly you can tell that the numbers are arranged in an ascending order. That is, as you move towards the right, the magnitude or the value of the figures increase. Alright, so that is what a number line is. So basically you have the negatives and the positives, right, and they are separated by the 0. Right, so this is a typical number line, and for any given number line you have a range. Right, you have a range. So here, for instance, the range is from -3 to +3. Right, so let's look at how to illustrate or represent inequalities on a number line. Right. So we've looked at the 4 types of inequalities. So let's look at how we can sort of represent these inequalities on a number line, right? So let's start with the greater than, right? So we have an example here: x is greater than -4. So how do you represent x is greater than -4 on the number line? Right. So first of all, we'll have to draw a number line, as you can see here. So this is it, and then we give it the calibrations, right? So we have -6, -5, -4, -3, and -2. Alright, now because it is greater than -4, at least you should know that then you have to include numbers that are bigger than -4. So for instance, -3, -2, right? So you have to also examine the kind of inequality or the interpretation of the inequality before you give the calibrations, right? So it shouldn't turn out that you have x is greater than -4, but then you have -4 as your highest number on the number line. No, it shouldn't be so. So before you give the calibrations, make sure you understand the implication of the inequality. So because it is greater than, then of course you have to include numbers that are greater than -4, right? Yeah. So the next thing is to draw a circle, right? A small circle on top of the number that comes after the inequality sign, right? So here it is -4. So you have to draw a circle on top of the -4, right? Now the circle must be unshaded, right? So it's just a circle, a blank circle, right? It must be unshaded, and then you draw an arrow line, right? So you draw an arrow, but because it is greater than, it will point towards the right, right? So the arrow will point towards the right, like I just told you that on a typical number line, as you move towards the right, the numbers increase, right? The numbers increase, the value of the figures, they increase. So if you want to communicate x is greater than -4, then of course the arrow must point or must head towards the right, right? So that is for greater than. Now let's look at less than. With less than 2, you have to of course draw the number line, give the calibrations, and the calibrations too, you have to consider the interpretation of the inequality. So since it is x is less than 6, then of course when you are giving the calibrations, or when you are giving the numbers to the number line, you have to include numbers that are less than 6. I mean, this thing is practical, right? It is practical. So we have our number line here. So the calibrations, we have 3, 4, 5, 6, 7, right? So as usual, you draw a circle on top of the 6, right? Now because it is less than, the arrow will point towards the left, right? Yeah, because as you move towards the left, the value of the numbers decrease, right? So because it's less than, the arrow face or point towards the left, right? And the circle must be unshaded. Since it is only less than, the circle must be unshaded, right? Okay, let's move on. So what if we have greater than or equal to? Greater than or equal to. So here we have x is greater than or equal to +2. So it is similar to the greater than, right? So you draw a number line, you give the calibrations, and then you draw a circle on top of the 2, right? But this time around, you are going to shade the circle because it is greater than or equal to. You are going to shade the circle, and then as usual, you draw an arrow pointing towards the right, right? So that is the only difference between greater than or equal to and then just greater than. With just greater than, the circle is unshaded. With greater than or equal to, the circle is shaded, right? Okay, let's come to less than or equal to. So with less than or equal to, this one too is similar to the less than, The only difference is what, that you shade the circle, right? So you shade the circle and then the arrow moves, or it points towards the left, right? So that is less than or equal to. Now let's look at these two other illustrations of inequalities on a number line. Now there are times that you be given a range, a specific range, right? So you be given the lower range and then an upper range, or let me say a lower limit and an upper limit, right? So you see, with the ones that we've done so far, for these four, you can't really tell the limit. For instance, if I say x is greater than or equal to 2, it means that x can be 2 itself, right? X can be 3, x can be 4, 5, 6, 7, up to infinity. You can't tell when, or you can't tell the upper limit, right? Because it is greater than. So in fact, any number that is bigger than 2 is greater than 2, right? So it says is x is greater than or equal to 2. So what this means is that x can be 2 itself, or it can be more than 2, right? But then we don't know the highest number that will be covered by this inequality, because if you say x is greater than 2, you can have 1,000, you can have 1,000,000, you can have 10 million. So it goes on and on and on to infinity. So we don't know the upper limit, right? Here too, if I say x is less than 6, x is less than 6, it means that any number that is less than the number 6 falls within this particular inequality, or is covered by this inequality, right? So with just the greater than, less than, greater than or equal to, less than or equal to, there is no specific range. You don't know the upper limit or the lower limit. But there are times that you be given a range, so the range will specify the lower limit and then the upper limit, right? So let's look at how to represent such a range on a number line, right? So this is what we refer to as a double inequality, the double inequality. So these four are single inequalities, right? And then these two are double inequalities. So you'd have two different, or they can even be the same inequality sign or symbols, right? So first of all, let me show you how to interpret or read the inequality, right? So usually the variable falls in the middle. The variables fall in the middle, or appears in the middle, and then you have the two figures at the ends, right? At the end, so you have a number starting and then you have another number ending. And then in between each number and then the variable, you have an inequality sign, right? So in between -1 and x, you have this sign here, this inequality sign or symbol. Between x and 3, you have this inequality symbol. Like I told you, that how we interpret or how we define a particular inequality is in respect of the position of that inequality against the variable, or where the variable is as against that inequality, right? So you don't say this is less than. You see, we said that, okay, so you see with this one, the positioning of this inequality sign is the same as this one, right? But this one is read as x is less than or equal to. But when you come here, it doesn't become x is less than or equal to. Now, like we said, for it to become less than, it means that the pointed end must face that variable. Here, the pointed end is not facing the x, it is rather the open end. So how do you read this inequality? It is x is greater than or equal to -1. I believe you are seeing it. So this is x is greater than or equal to -1, right? When you come to this side too, Now the pointed end is facing the x, so it becomes less than. So this one we read it as x is less than 3, right? So it means that we've been given a range. So what this inequality is saying that x must be higher than or bigger than or equal to -1, but it must be less than 3. So it means that if I ask you to list the numbers that fall within this range, you will tell me it is going to be -1, because -1 is less than or equal to -1. Alright, so it is -1, 0, greater than. So yes, x is greater than -1. X is greater than or equal to -1. So if I ask you to list the numbers that appear within this range, it's going to be -1, 0, +1, and then 2. Right? So with this one, we know our lower limit and then our upper limit. So our lower limit is -1 and our upper limit is 2. Right? It means that x must not be up to 3. It must be less than 3. Right? So that is this inequality for you. So how do you represent it on the number line? So as usual, you are going to draw your number line, give the calibrations, right? And then you see here it says x is greater than or equal to -1. So we are going to pick this one and then analyze it separately, right? So assuming the inequality were only x is greater than or equal to -1, so just as you apply your knowledge on greater than or equal to, you draw a circle and then you shade it. Because it is greater than, yeah, it's going to point towards the right. Right, it's going to point towards the right. Right, so that will be for the -1. So that will be for the first aspect. Then you come to the second part. X is less than 3 as well. So less than 3, so you're going to draw a 0 on top of the 3. You won't shade it. And then of course the line will what? The line will have to point towards the left. So you have one line pointing towards the right, another line pointing towards the left. Obviously they are going to meet, right? So it's going to form sort of a straight line, right? So the simple thing you can do is that just draw the circles on the two numbers, right, with respect to the type of the inequality. So here, because it is greater than or equal to, we shaded the -1. Here, because it is only less than, we didn't shade it, right? And then you just connect these two circles with a horizontal line. That is all. You don't have to bring any arrow, so you don't have to use any arrow, so you can just draw the horizontal line to connect these two circles, right? So let's look at this second one too. So how would you read this inequality? So you have to start from where the x is. So this one is x is greater than 5 but less than or equal to +9, right? So because it's greater than 5, you are going to draw a circle on top of the 5. We won't shade it because it's just greater than. And then less than or equal to 9, so you're going to draw another circle on top of 9, and then we will shade it, and then we will simply connect these two circles with a horizontal line. As simple as that. So that is how to represent or illustrate double inequalities on the number line. So these are the single inequalities, and then these are the double inequalities, right? Okay, so let's move on. Alright, so how do we solve linear inequalities? So like I said, it is the same principles you are going to use, just as we do it under equations, right? Just as we do under equation. So of course, if there are brackets, you have to expand the bracket. You have to group like terms, and then in grouping like terms, if a positive term crosses the inequality sign, it turns negative, and if it is a negative term, it will turn positive, right? So these are basic rules or guidelines that should help you to solve an inequality question. And then of course you have to reduce the coefficient of the variable to 1 by dividing both sides by what? By the coefficient, right? So it is the same thing. It is the same thing as we saw under equations. But then one special rule that you have to take note of is this. Now, with inequality, we are very much particular about the position of the variable with respect to the inequality sign, right? So if it happens that the coefficient of the variable becomes negative and you are dividing both sides by the negative coefficient, now after dividing both sides by the negative coefficient, the inequality sign is going to turn to the opposite direction. So if, let's say, you had negative x is less than, let's say, 4, negative x is less than 4, and you were dividing both sides by negative 1 so as to eliminate the negative operation. Now after dividing both sides by the negative 1, you are going to have x is greater than 4. Sorry, x greater than negative 4. I said if you had negative x is less than 4, obviously you have to divide both sides by negative 1. Now after doing that, the moment you divide both sides by the negative coefficient, the inequality sign is going to change to the opposite symbol. So if it were less than, after the division it will become greater than, so it will become x is greater than negative 4. I believe you are getting it. Now the same way, if it was negative, let's say negative 2x is less than or equal to 6, when you divide both sides by negative 2, so you are going to have negative 2x over 2 less than or equal to 6 over negative 2. So that is going to give you x is greater than or equal to negative 3. So the moment you divide through by a negative coefficient, the inequality sign reverses, right? It reverses. So if it is less than, it will change to greater than. If it is less than or equal to, it will change to greater than or equal to, or vice versa, right? Okay, so we'll be taking some examples, you understand it better.